So function notation for piecewise functions is similar to what we did when we just did regular function notation. I want you to remember that this value inside your parentheses represents the x value of your function. And what we're trying to figure out is when you take this x value and you plug it into an equation, what's the y value going to be? Okay, the only difference between function notation and a piecewise function is before you can plug this x into an equation, you have to figure out which equation you're going to use. And that's going to be based on the domain restrictors. Okay, so right here I have an x value of positive 3. So what I need to do first is look at these two domain restrictors and figure out which one of these is going to give me a true statement. So for example, 3, if I plug it in here, is 3 less than 4? Or if I plug it in here, it says 3 is greater than or equal to 4. Well, this isn't true. 3 is not greater than or equal to 4. So that means I'm going to end up plugging this into this first, this is where it fits in the domain restrictor. I'm going to plug it into this first equation. Okay? So with that, okay, I'm going to use the red equation here. And I'm going to start by writing that equation out, x plus 5. And then the rest of it is just like what we used to do. I'm going to take this x value and plug it in, and then I'm going to solve it. So f of 3 equals 8, which means on a graph this would be your ordered pair, 3, 8. So now let's look at f of 4. If I plugged it in here, it says 4 is less than 4. That's not true. If I plug it in here, it says 4 is greater than or equal to 4. Well, it is equal to 4, so that means we're going to use this blue equation right here, this negative 2x minus 1. So again, I'm going to start by writing that down. Then I'm going to take this value and plug it in for x. Okay, and then we're going to do negative 2 times 4 gives me negative 8. Negative 8 minus 1 gives me negative 9. Okay, last but not least, look at your negative 2. Decide where it goes. Hopefully you decided it was here because negative 2 is less than 4. So again, we're going to use this equation. We're going to plug it in. Oops, sorry. We're going to get negative 2 plus 5 equals 3. Okay, so we're going to do a couple of these problems together just so you can see some different things, and then there'll be some problems for you to try on your own. So we have g of negative 4. So you're going to look over here and figure out, is negative 4 less than or equal to 2? Yes. So in this case, we're going to use our green equation. So we just start by writing that equation out. Okay, I'm calling them equations. They're really expressions. So negative 2x plus 1, and then you plug this in. Be careful when you're plugging in these negatives. Remember, you're replacing only the x. So we have negative 2 times negative 4 plus 1, which would give me 9. Then you go to the next one, 8. Well, in this case, 8 is greater than 2. So we're going to use this expression right here. Okay, and we plug in our 8, and we multiply it out, and we get our answer. And again, g is equal, or g of x, we got an x value of 2, sorry. That's going to go into this green expression here because 2 is less than or equal to 2. And again, we just use this expression, we plug in, and we solve. Okay, now there are two situations I want to talk to you about, so I'm not going to do these whole problems with you. Okay, this one I want to talk to you about this part right here. Okay, this isn't an expression. Okay, it's not like we have something that we're going to plug into. But what this means is anytime we get a number that's less than or equal to negative 3, our answer is just 5. Okay, there's nothing to do. You just put down 5. So if you think about this on a graph, this would be like where the horizontal line is on your graph. Okay, so if x is less than or equal to negative 3, well, that's negative 4 here. So for this, we're going to use this red expression, and all we do is just put that value 5. And it seems almost too simple, but that's what you do. Okay, so here, h we need to see is 0 greater than or less than negative 3. It would be this blue expression we're going to use because 0 is greater than negative 3. And again, you're just going to solve it. Okay, take a minute, figure out which expression this would use. Hopefully you see it's the blue one also. And we're going to plug in and solve. All right, so one more thing that I want to show you, and I'm not going to do everything here because it's pretty redundant, but I want you to see the fraction, okay? if you have a fraction, don't worry about it too much. So x is greater than or equal to 2. So I'm just going to use this number here because this is the one that would go with this green expression. Okay? If you have a fraction, you're going to do the problem the exact same way. So we're going to have 1/3 of x. Okay? We're going to replace that x with our 3, 1/3 times 3, which is essentially saying what's 1/3 of 3? And 1/3 of 3 is just 1. Take some time, do these other two problems. I'm just going to show you the answers quickly. Hopefully you found them. Okay. And then the rest of this paper, there are a few more problems on this paper. Go ahead and do them for practice because there are a couple other situations. Okay?